We are happy to be the first one who present here. We are going to present how we use the Qt framework as part of our device. So first I'll start by telling you about our company and our device, and then Asaf will take control and show and drill down about some technical issue. So we are Augmedics. We are developing an AR navigation system for spine surgery. Our product is called Xvision, and I'm just going to talk about it. Our founder is Eliah, and these are the other management team. I'm not going to dig with each one, but as you can see and search afterward. So what is the Xvision? We are the first and only AR surgical navigation system in the world. There are other companies that has navigation system for spine surgery, but none of them are AR based. We are actually giving the surgeon a way to see through the patient back and to do what he needs to do with the vertebrae and spine. So today, other competitors, what they are doing, they are actually doing the surgeon on the patient back, but they are looking on a screen on the side of the patient, which show them how to put some instrument into the vertebrae. And as you can see, the eyes are not on the patient itself. This, of course, causes a lot of other problem and other issue for the surgery, but it's not good for the patient. So what we are doing already, it's allowing the surgeon to see through the patient anatomy and to see through his skin and to get some kind of superpower X-ray vision and to do what he needs to do to make the patient feel better again. So I'm going to show you a bit of a short movie clip. I hope it will work. And then I continue to talk about the device. Okay. I hope everyone here.
It was pretty fancy when I first saw it because it was the first time you could really see three-dimensionally through a phantom of fake spine. I was pretty surprised at how fast I was able to adopt the techniques with the Xvision in the short period of time that I used it. Typically, what we have to do is we have to look away from where we're working. But this has all the image guided information within the goggles that you're wearing while you're placing the instrumentation. As I turned my head and looked like an old person would look at a patient, I could actually see the details of this three-dimensional anatomy basically through the patient. This gives you added confidence, I think, in real-time confidence that you're placing the instrumentation in the correct location. And I think that's really pretty cool. Imagine if you were driving a vehicle and your GPS, what it was trying to is, you want the GPS intuitively displayed translucently onto your windshield so that you're still always looking at the road, versus what you do now where you're looking at a GPS down on a console or on your phone. So the Xvision setup with the optics onlay is really no different than wearing some type of shield, which is often what surgeons do. This was actually made easy to use and it was translucent. You can see through the actual image. Anything that improves your surgical efficiency in many ways is going to be better. We can increase the information we gather. This is all going to lead to efficiency. This is going to lead to better outcomes and simply to better safety. The number one benefit for Xvision is that you are always looking at the patient. You're never distracted from the patient. The patient's in the operating room for less time, which means that it's safer and it's also easier for the surgeon. If we take this technology at face value right now, it's a game changer.
Okay. So let's continue. We are happy to be a game changer, and in this field, as you saw in the movie clip, we are putting the eye of the surgeon on the patient, which increase safety and also the outcome of all the surgery, which is complicated from the beginning. So our device is actually two component. We have the headset, which is here, and we have all-in-one PC that control the headset. The headset is connecting through wireless communication. We have those lenses here, which are the screen where we put the patient anatomy and his CT scan. We have here a tracking camera that see all the tools and stuff that need for the surgeon. Our competitors have camera around the patient, and we have it on the patient, on the surgeon head. We are very accurate, which is also very important in such surgeries. The headset is personal for the doctor, and let's go in, but this navigation system gives some X-ray vision to the doctor that do the surgery. So we got our FDA clearance the beginning of this year on January, and we are working on another CE certification. So as you know, we are a medical device company. We need this clearance to start the selling. The product is already working on the US market, and we hope to get to the European market soon. So why we choose the tool, why we choose Qt for our device. So cross-platform is very important for us. We have the all-in-one PC, which run in Windows, and we have this headset that has the Jetson TX2 Nvidia-based platform, which working on Linux. We use a Qt image for the Jetson based on Yocto Linux. We need different kind of gesture, touchscreen gesture, mouse gesture, or maybe in the future even hand gesture. We needed debugging abilities, either for the local Windows and the cross-platform performance, and we need compliance. We need to be able to work with C++ that has a lot of static analysis, coverage, profiling, and additional tools that we need for our regulatory clearance. We use the framework of Qt for automating tests, for UI, of course, and 3D is one of our major requirements. And one of the very good issues that we have by using Qt is the support that we need to use every once in a while, and we get a good reference from. So I'll move the hands to Asaf to drill down for the technical stuff. Thank you. If you have questions, we have a Q&A at the end.
Hi guys, 1 second. So hi everyone, my name is Asaf and I'm a computer vision engineer at Augmedics. I will start by reviewing some case studies just to demonstrate our use of the Qt environment. So first of all, let's talk about the QML. Basically, the language supports our user interface. The QML is the Qt modeling language. Coding our application layout and creating our own UI components is simple, as you can see in the code snips presented. So on the left image, you can see how we're building the up button QML file out of QML native types, which is the text, mouse area, rectangles, which pretty much everyone already know. And on the right image, we can see how we are reusing the up button component in another QML file. You can see it's very readable and simple to reuse. our previously created components. So that's one thing. Another thing is that the QML supports inline JavaScript. We use it for fast and simple functionality. As the left image show, you can see right here that we are just using the inline Java functionality to assign a string variable. But we also can use it for triggering some high-consuming CPU and time tasks. Like you see over here, we can reloading some volume. Natively, those tasks will be executed on different processes and threads than the main GUI thread. We're doing it for keeping the GUI responsive and making him free to process other events in the meanwhile. So we also use Qt properties signal slots mechanism in order to define the relationship between the module supported in the QML scene, the native QML one, and the one we register, the customized QML objects. So in the image, you can see basically two string properties declaration. The property has its own getter, setter, and notifier, which is basically like any other property. You can see we have the C++ declaration in the middle and the QML declaration in the top of our screen. I might add that in the QML section, all the signals, the getter, the signal are all implicitly created behind the scene for you, so it's very straightforward, only declaring the property, and that's it. In the lower part, where you can see the laser, there is the binding mechanism, which we basically bind the QML string property into the C++ property defined in our QML registered object. So basically very simple. So another thing we use QML too is, until now we just saw the GUI application, but we also have our own 3D scene to combine with the GUI scene graph. So basically, beside the fact that it's convenient and readable, we can combine all of them in a QML file only with the help of the scene 3D object, which is a native object provided by QML, responsible for synchronizing both the 3D frame graph and the 2D string graph into one synchronized huge graph. So you don't have to invest anything, but only to use the native types. Like you can see in here, it's very, very convenient. As an example, we can see that our workstation application rendering the 3D scene right in the middle, where you can see the laser, the 3D anatomy for in this example. The Qt 3D provides high-level API, enable us to create 3D scene without implementing any OpenGL from scratch, like I used to do in the past. In addition, the Qt 3D has a set of default uniform exposed to GLSL shaders if you are programming any shaders. So again, very convenient and saves you like tons of time. This application specifically runs on both Windows 32 and 64 bits without any change of code, which brings me up to my next case, which is the cross-platform. Our application can run on Windows and Unix operating system. Since Qt module supports cross-platform, it's easier to maintain our application cross-platform as well. Running the same code on embedded side over Windows platform help us to develop faster and independently from external hardware. Basically, we're creating our own simulators, and we don't need any hardware to test our application. Here you can see some example of using two shader configuration, one for the OpenGL for one, which is the Windows desktop, and one for OpenGL embedded system on the lower part. During runtime, the application just selects the right configuration based on the platform it is running on. So I'm going to show you an application we have created just to demonstrate that we take all the stuff we talked about and make it more visualized. So I'm gonna display it. Just 1 second. Okay, it's not moving. Okay, now it's moving.
Yeah.
Just 1 second, guys. Okay, so I hope you can see it. So in here you can see another application we've created. You know, the 3D scene is right in the middle. We have all the buttons over here which control our shaders and our uniforms in a very synced and in, I don't know, developer-friendly way. So you can see it's very cool, very easy, and that's about it. I hope it was interesting for you guys. I'm done, so thank you very much.
That's it. We are open for Q&A. If anyone has something to ask, you are looking on the Q&A section here. Okay. And your broadcast. You're now live. Okay, I'm live. Okay. So I see we don't have any questions.
There was a question regarding the FDA cleared, what it really means. Does it comply with EIC 62304 for software development?
Okay, I will see. I didn't hear the question. Can you say some words on interaction between Nvidia and PC system? Okay. We are using communication, a TCP communication to communicate between the Nvidia and the PC system. So we are having our protocol. We are using, of course, Qt single and slot for doing that, but it's a simple communication between two processes. I think this was the question. I need to see the question in the chat. I thought in the Q&A. And let's see if there is another one. Victor. I have question about FDA cleared. What it is really mean? Is it comply with 62304 for software development? I mean OS or Windows, Linux, not Autos. Okay, I'm not going to go into the clearance, but as you know, on a regulatory market, either automotive, medical, or aerospace and defense, we need some clearance. For the clearance stuff, we need to be comply with some standard. The 62304 we are comply with. Also, we need to verify our application, and we, as I mentioned, we got our FDA clearance, and they tested us and checked that we are okay or comply with everything that needed to put a medical device in the US market. Any other questions? Okay, I don't see more questions.
I think there's one in the Q&A as well.
Also there. Did you consider other alternative development tools than Qt when choosing a development tool? If yes, which one? So when we had the time to decide where we go, this one? Okay. So when we needed to decide whether to go with Qt or not, we have some alternative, but the other alternative had a real long time to market. I mean, we needed a 3D engine for our 3D stuff. We didn't want to write all the OpenGL stuff on our own. We could use direct OpenGL or using Vulkan or other 3D agent. But Qt gave us the overall solution for developing with the same code cross-platform without drill down to the low-level OpenGL, although we can with Qt. So this was the real advantage that we needed, thinking of time to market stuff, you know.
Okay, thank you. That's all we have time for today. So thank you so much for your presentation.
Okay, thank you.
Bye, Salah.
Bye-bye.